Advanced math. Starting off blurry. There we go. Advanced math lesson 86, arithmetic progression and arithmetic means. So if you're, first things first, if this is a trigonometry year for you and you're taking trigonometry, we're not supposed to do this lesson. I typically skip this lesson in the trigonometry year because we normally don't have enough time to complete the baseline knowledge. We don't get to finish the culminating event that this lesson teaches us. It's a baseline knowledge for something that you do later on in the book, but we're not going to get that far if we're doing the trigonometry version of the class. So if you're in the trigonometry version of the class, and I told you guys we're doing this lesson and then you're watching this video right now, send me a message and say, hey, Mr. Claiborne, in your video you wanted us to remind you that you're not supposed to do this lesson in trigonometry. So yes, this is me leaving a note to myself in the future when I forget, and I need you to pass that note for me to myself. Hope that's not confusing. Okay, now if it's not a trigonometry year and you're in pre-calculus, then yeah, this is one of the first lessons we're doing throughout the school year. And it's a good baseline lesson because arithmetic progression and arithmetic means ends up being something that we end up building on. It's an idea we expound upon throughout the year. But main thing I'm going to break down are the words. So not often do I spend time with the camera looking at the title of the lesson, but let's break down the words. Arithmetic, and arithmetic shows up in both. Arithmetic referring to our four basic operations of addition, subtraction, multiplication, and division. In this case, it's going to be mostly focused on addition and subtraction. Progression means a sequence that progresses or changes. And then mean, which is the word you should already know, average, right? So arithmetic progression simply refers to a number that progresses, and the arithmetic mean refers to the rate of that progression, or the average, the average difference of that progression. So quick example of what in the world all this stuff looks like. Right here in A, we have a set of an arithmetic progression. Here, number 7 would be referred to as the first term. Each number in an arithmetic progression is called a term. 7 would be term 1, term 2, term 3, term 4, etc. Now, if we look at this set of arithmetic progression, we can find out what the arithmetic mean is. The mean is what happens between each number. So if we go from 7 to 10 to 13 to 16, we'll see the trend very quickly as we add 3. 7 plus 3 is 10, 7 plus 3 is 13, 13 plus 3 is 16. So the arithmetic mean is positive 3. Now let's look at the bottom. We go from 7 to 3 to negative 1. Looks like we lost 4, and we're losing 4. So here, the arithmetic mean would be negative 4. And the way these are read is this one, we would say that subset A has an arithmetic mean with a difference of, subset A has an arithmetic mean that shows a difference of 3. On B, we would say subset B has an arithmetic mean that shows a difference of negative 4. So they're going to use the phrase difference for both positive and negative numbers. If the number is marked as a positive number, then you'll be adding. If it's marked as a negative number, you will be subtracting. But they're going to use the word difference on all of them no matter what. Let's go ahead and start with a really quick example. 86.1, this one is pretty easy. They tell us to write the first 4 terms in an arithmetic sequence whose first term is negative 14 and whose common difference is 10. Okay, so common difference is 10. All I have to do is go over here, start off at negative 14. Why is my lighting so weird? Start off at negative 14, and then I'm going to add 10. Negative 14 plus 10 is negative 4. Negative 4 plus 10 is positive 6. Positive 6 plus 10 is 16. And there we go. I've got the first 4 terms of an arithmetic sequence whose first term is negative 14 and whose arithmetic mean is a difference of 10. And there we go, I did it. Now let's try to find another example. It's a little bit harder. Let's see here. Let's talk about some notation before we do that. That one looked promising. We'll do some notation here. This one, 86.4. They say write the first 5 terms of an arithmetic sequence in which A17 equals negative 40 and A28 equals negative 73. So they just took a huge leap in logic there. What in the world does all of this mean? Well, remember how I was talking about how each term has a number, like term 1, term 2? A17 means term number 17. A28 means term number 28. So we have to find the first 5 terms in an arithmetic sequence where the 17th number is negative 40, and the 28th number is negative 73. Wow, right? Okay, so what can help us understand this is if we draw like a number line diagram, and our number line is going to be a little lost, I guess. So let's say, well, I don't even want to put 0 on this number line because I don't know where it's going to go. So let's say they're saying that A17, so number A17, arithmetic number 17 is negative 40. And then they're saying that arithmetic number A28 is negative 73. And I just realized my camera's out of focus. That's got to be so annoying sometimes. Okay, now we have to figure out what the first 5 numbers are, but the problem is we're like, how in the world are we going to figure out what the difference is from 17 to 28? Well, let's start by giving us another unknown. Let's call A1 the starting number, the first term in the arithmetic sequence. We have to figure out what that is. So we'll go ahead and call A1 X, because we got to figure out what it is, right? So this gives us the ability to write 2 equations, okay? So what we can do here is we can say that the arithmetic mean, we'll call that M, plus or minus M. That is going to happen how many times before we get to 17? So if we're starting at X, we're going to have to add or minus whatever the mean is 16 times before we get to 17. And then we'd have to do it 27 times before we got to 28. So that is the knowledge that we're going to use, our knowledge of the arithmetic sequence, the knowing that it's going to do the same thing over and over and over again. So our starting number, X, if we want to get to 40, if we add the mean times 16 times the mean, if we add that to X, we're going to get negative 40, or sequence number 17. And then we can do the same thing with 28. We're going to take X and we're going to add not 28 but 27 times the mean. Pen is bleeding. And that will give us negative 73. Okay. So from here, now we have 2 systems of equations. We can either substitute or eliminate, or we could use Cramer's rule. We can use matrices, whatever we want to do. But I see really quick here that's really fast to eliminate. All I have to do is change all the signs in one of the equations. So that's what I'm going to do. I'm going to make this a negative. This will become negative 27, and this will become positive 73. So when I combine these, the x's will cancel. Positive 16 plus negative 27 is going to give me negative 11m. And then 73 minus 40 is going to give me 33. Hey, so if I divide that by negative 11, it looks like my mean is going to be negative 3. So if my arithmetic mean is negative 3, which seems to fit since our number is going down even farther into negatives, all I have to do to figure out x is do another equation. So I'll plug this back into one of these. So we'll see here. Let's take x plus 16 times the newfound mean of negative 3, and that's going to equal negative 40. All we have to do now is solve that. And let's see here. I'm trying to remember my 16 times tables. 10, negative 30, 6 times 3, 18, negative 48. Okay, so this becomes negative 48 if we add it to each side. It's going to cancel, and then I'm going to get x is equal to positive 8. So my first number is 8. Now, if you remember, the question was asking, we need to find the first 5 terms of this. So if the first term is 8, then the second term, minus 3, is going to be 5. The next term, minus 3, is going to be 2. The next term, minus 3, is going to be negative 1. And then the last term that we need to find is going to be negative 4. We got it. Okay. That is the first tough example. Let's see here. There's one more tough example, I think. Let's see if we can figure it out. All right. So let me get my camera focused. Now, this one says, find the 10th term of an arithmetic sequence in which the first term is 3x plus 2y and the sixth term is 8x plus 12y. Some of you are totally losing your minds right now. You're like, this is craziness. No, good thing is this uses the exact same logic that we just used in the previous question. We just have to find term number 10. We have the first term, and we know the sixth term. So, okay, so we'll call it A1. Term 1 equals 3x plus 2y. So on our little number line here, we would say term 1 is 3x plus 2y. Term 6, this is 1, this is 6, we got to find 10. 6 is 8x plus 12y. If you remember, from term 1 to term 6, we have to add 5, or 1 less of whatever term you're at. So we could say that this plus 5 times the mean is going to equal that, which is what we're going to do. The mean is unknown, and A6 equals 8x plus 12y. So we'll take this equation and set it up. Let's go to orange. So A1 is 3x plus 2y, and then if we add 5 times the mean, 5 times m, we're going to get the sixth term, which is 8x plus 12y. Great. So now, let's see what we can simplify. First thing, I want to move these to the other side, so let's do that. Let's move negative 3x minus 2y, negative 3x minus 2y. So then I've got 5m is equal to 5x, and then plus 10y. From here, all I'm going to do is simplify m. So I'll divide everything by 5. Which is actually going to work out really nicely in this problem. It's not all the time that you get whole numbers when you have to divide polynomials like this. So once I do that, m is going to equal x plus 2y. So some of you are thinking like, Mr. Claiborne, we still haven't solved anything. If you remember, our numbers are in terms of x and y. We know what our arithmetic mean is. All we have to do is add this to our number. So if our arithmetic mean is x plus 2y, and we have to find the 10th term, then the 10th term is just going to be the first term plus 9 times the mean, right? So the first term, right here, we just take this and add 9 times the mean. So the mean is m plus 2y. If I take 9 times that, I'm going to get 9x plus 18y, right? So 9x plus 18y plus 3x plus 2y is going to give me what? 12x plus 20y. So the answer is 12x plus 20y. That's it for today's lesson. If you have any questions, let me know on the school's website, and I will see you in class.